Okay, what we see here is just a repeat of what was on the preceding video, so we're just going to ignore this part of the board and move to this question. Okay, if I sell 200 widgets for $5 each, what are the price, the number sold, and the revenue? Now, price, we use P. Remember, if we do a graph of X, number sold, versus P, the price, X is the number sold, P is the price. Price P. Well, that's our $5, isn't it? How many sold? Well, that's our 200 that I sold. It says so right there. That's 200. Now, let's say I'm selling my knives again, and I sell 350 of them for $1.50 a piece. That, how much money do I get? What's my revenue? Well, you probably answer, and you want to think this through. Think through your answer. If I sell 350 of these for $1.50 a piece, how much money am I going to take in? What's going to be my revenue? Well, it's going to be $350 times $1.50, which is, I think, $525. Okay? You can check my arithmetic. Now, what do? How do we find our revenue? We multiply the price by how many we sell. Okay, so that's really pretty obvious. We multiply the 200 that we sell by the $5 that we sell them for. We get $1,000. So the revenue is the number sold times the price, and we could abbreviate that in terms of the symbols that we use for this situation as X times P. The number we sell is X, the price is P. So just a little preview, that's how we get revenue if we know price and how many we sell, if we know P and X. Now, the revenue, or the demand function, I'm sorry, that we're given is P equals negative 0.2X plus 5,000. Now, if it's P equals some function of X, that means we're going to put X on the horizontal axis and P on the vertical axis. Now, we can graph this. Well, we can easily find the intercepts, okay? And remember, the intercepts have an interpretation. Each intercept has an interpretation. So to find the P-intercept, well, the P-axis is characterized by the fact that on any point on the P-axis, the X-coordinate is 0. So we plug in X equals 0, and we get P equals 5,000. So the P-intercept is 5,000. The X-intercept we get by setting P equal to 0, and we get negative 2.2X plus 5,000 equals 0. We solve that for X, and we get X equals 25,000. I'm going to actually write in those equations and calculations real quickly. Okay, this is something you should be very well versed in, but just to be sure, to get the vertical axis intercept, you let the horizontal quantity be 0, X is 0, so X equals 0 implies that P is 5,000, giving you the point 0, 5,000, this point, which is on the P-axis. And P equals 0 means that negative 0.2X plus 5,000 is 0. And we solve that equation, and the steps are very simple. You end up with X equals 25,000. Now, those values have interpretation, as we saw previously, and as is kind of mentioned here also. The 5,000 is the price at which the number sold first reaches 0. Okay, as the number sold decreases, well, that happens because the price has gone up. And as X approaches 0, price approaches 5,000. Okay, now this isn't a cause and effect. Usually, again, if it's a cause, it's the price that's causing the X, not the X that's causing the price. So this graph is sort of backwards, but that's the way the function was given, so we're going to deal with the graph as it is. We still got a good function. And the 25,000 says, well, if we drop the price to 0, then we're going to sell 25,000 of these things. Okay, so next question. If 10,000 are sold, then what would the price have been? Okay, well, if we sold 10,000, that means that P is going to be 10,000. I'm sorry, that X is going to be 10,000, and we want to find the price. Well, this form of the function is convenient for doing that. If we know how many are sold, then we can figure out the price. Of course, again, if we're making decisions, we decide on the price. We don't decide on how many are sold. So this seems a little weird to me. The other order, if we had x equal some function of p, would seem to make more sense in my way of thinking. But this is going to be actually more convenient to answer the question we have here, which is why it's set up the way it is. And we'll see what I mean in a minute. Okay, so if 10,000 are sold, what was the price? Well, we plug in 10,000 for x, we get this equation. I'm not going to read it to you. And we multiply things out, and we quickly determine that the price must have been 3,000. Okay, well, in that case, then what was the revenue? Well, 3,000 price, that might be $3,000, multiplied by the 10,000 we sold gives us 30 million. Okay, and if these are dollars, that's $30 million. So, again, number sold multiplied by the price, multiplied out, get $30 million. Now, I ask, okay, if 10,100 are sold, then what was the price? Well, you plug in the 10,100 for x and multiply it out, and you're going to get 30,098,000. I'm sorry, you're going to get 2,980. Okay, and you multiply that by the 10,100 that you sold, and you get 30,098,000, presumably dollars, in revenue. So that what happens here is this is a lower price than this. The price is $29.80 here when your revenue is $30,098,000, and your price is $3,000 when your revenue is $30 million. Meaning that the lower price gives you the better revenue. Okay, that's a little bit counterintuitive, but if you lower the price, you gain sales. Now, sometimes lowering the price will gain sales, sometimes it'll lose sales. It depends on what the original price was. And sometimes you'll gain and sometimes you'll lose revenue by changing the price one way or the other. In this case, the question is, should we increase the price? And the answer is clearly no. We go from $29.80 to $3,000, and we lose $98,000 in revenue. And if we increase the price some more, we expect that that trend might continue. So no, we don't want to do that. Okay, the decreased price increases the revenue, and I say around a price of $3,000. If the price was something different, if the price was, say, $1,000, then it might well be that increasing the price would increase the revenue. Okay, so this is just an exercise in getting the feel for this type of situation. What we really want to do is we want a symbolic expression that gives us our revenue in terms of the number sold or in terms of price, depending on which way we want to look at it. So, suppose that x is the number we sell, which is, of course, what x stands for. Then the price is negative 0.2x plus 5,000. So what's the revenue? Well, the revenue is the number we sell times the price, which would be x times negative 0.2x plus 5,000, which is then negative 0.2x squared plus 5,000x. And this is our revenue function. Now we'll go on and look at some characteristics of the revenue function, but this is how we get the revenue function. Now, to put it concisely, if we have our price function, we can multiply it by x to get our revenue function, right? So, and then we do some things to investigate maybe what demand, what number x, gives us the maximum revenue, and then we set our price accordingly.